Complementarity Principle. This idea was proposed by Niels Bohr in the year 1927. Complementarity Principle, this is the topic of discussion in today's lecture. Okay, and this topic you would find in the subject of quantum mechanics. You know that quantum mechanics is notorious for its principles, okay, which do not match with our classical intuition. Means if you study classical physics and then you would study, if you study quantum mechanics, then you would find that the ideas in these two subjects are not matching with each other. Our day-to-day life experience is just like the principles of classical physics. But whenever you study quantum mechanics, then there you would find such concepts which do not easily match with your intuition or with your knowledge of classical mechanics or classical physics. Okay, so here in this context of complementarity principle, and you know that this principle is applicable for quantum system such as electrons, photons, protons, etc. Means particles at the fundamental level or smallest scale. Okay, particles at the smallest scale or quantum system at the smallest scale. For those things, this principle is applicable. If you focus on double-slit experiment, you know that for electrons, the double-slit experiment was done, okay, was conducted. Again, for photons, the same experiment was conducted. And you know that when the experiment is not observed, in that case, wave-like pattern of both the photons and electrons are observed. On the screen, interference pattern is obtained, and that interference pattern reveals the wave-like behavior of photon and electron. I am using as an example electron and photon, whatever be the particle. If it is a quantum system, means if it is very small, if it is subatomic particle, then in all those cases, the same pattern you would observe. So when the experiment is not observed, in that case, wave-like pattern is being demonstrated by the quantum system. But when the experiment is observed, in that case, particle-like behavior is observed. And that is why this is called dual nature of particle. Both the wave-like nature and the particle-like nature, both are available, both are observed, but not at the same time. They cannot be observed simultaneously. Either of the two can be observed. Okay, so it depends upon the experimental setup. It depends upon the experimental setup. Again, there is observer effect involved in such experiments of quantum systems. Okay, and you know that if you talk about superposition principle, you know that all the possible outcomes of a quantum system exist simultaneously, and this is called superposition. The quantum system remains in a superposition state. It is a superposition of all the states, means all the possible outcomes, and whenever a measurement is made, only one outcome is observed. Only one outcome. Whenever a measurement is made. Again, there is uncertainty principle. You know that uncertainty principle. Say if you talk about a pair, position and momentum, then if you can measure the position of a particle precisely, then in that case, the momentum of the same particle cannot be measured precisely. If precision in the measurement of position is more, then the precision in the measurement of momentum will be less. That is uncertainty principle. So these all things are being supported by the complementarity principle. Actually, what is this principle? This principle is that both the nature of the particle exist simultaneously but cannot be observed simultaneously. Similarly, I have already mentioned that all the possible outcomes exist simultaneously, which is known as superposition. Okay, but whenever it is measured, only one outcome is observed. So, complementarity principle also states the same thing. It depends on the experimental setup. It does not mean that you are getting one outcome, that means only that outcome exists, the other does not exist. Not like that. Both are existing together, but we can observe only one outcome. That is the concept behind this complementarity principle. Okay, and this is notorious. I have stated like that. This is notorious because this is not matching with our classical intuition, or this is not matching with the knowledge of our classical physics. In classical physics, you know that any particle or any object can be defined precisely by all its parameters. Position, momentum, energy, everything can be known simultaneously with arbitrary precision. But in case of quantum mechanics, all the parameters or all the variables cannot be known simultaneously with arbitrary precision. So I was talking about only one pair, position and momentum. Again, if you move to next pair, such as energy and time, the precision with which the energy of a system can be measured, with the same precision, the time at which the energy was measured cannot be known. Okay, suppose at a particular time the energy of a quantum system was measured, but after measuring that energy of the quantum system, the exact time at which that energy was measured cannot be known simultaneously. And this is uncertainty principle. Okay. Anyway, so this was all about, and the famous experiment in this context is Double-Slit Experiment. Okay. Anyway, so this was all about complementarity principle, which was introduced by Niels Bohr in 1927. Okay. Okay, so this is the end of this video. Thank you for watching this video.